Hi everybody, I'm Amanda and I'm here with Emma on the LunaSat, and we're going to be going over Module 4, Activity 1, Temperature Data. And you're going to need a few materials for this, which are your LunaSat, your computer with the Arduino IDE installed, your FTDI and the associated cables, and then your Activity 4.1 worksheet, which is called Temperature Data, so follow along on that. And then the code, we're going to go ahead and open that now. You're going to go under Examples, Glee 2023, like normal. Module sketches, we're in Module 4, and then we want temperature basic example. And in this activity, you're going to put your LunaSat into different thermal environments in order to see the temperature change. The temperature sensor prints data at a regular interval, which is 1 measurement per second. And when you observe that in the serial monitor or serial plotter, it should give you data that looks like the plot on the right of this slide. All right, so you want to start with your LunaSat at room temperature. So put your LunaSat on the table in a spot with no direct sunlight and without a large heat source nearby, but still close enough to your computer so that you can plug it in. Then you're going to connect the LunaSat to the FTDI and your laptop, and connect the board and processor and port. So we want to check that it's on the right board, and we have the right processor, and we do have the right port selected. Next up, we're going to upload the code. So it's going to compile, upload, and this can take a little bit. Now it's done uploading, we can go to Tools, and we're going to open Serial Plotter. And now we're looking to see that the temperature sensor is in fact measuring room temperature. So that should be around 70 degrees Fahrenheit or 21 degrees Celsius, but it can definitely vary based on what room you're in. So mine looks to be about right. We have around 75 degrees and around 20 degrees-ish. So document this on your worksheet. And if you want, you can comment out the Celsius or Fahrenheit lines, and then you will only see one or the other. And now we're going to expose the LunaSat to a heat source, and we're going to monitor how the data changes. So let's look at our serial plotter. And Emma's going to gently place her finger covering the whole sensor and keep it there for about 30 seconds. So she's placed her finger on the temperature sensor, and you can see the temperature increasing there. And you'll observe like this large jump at the beginning, and then it'll slowly approach an equilibrium temperature, which is why you want to hold it there for maybe about 30 seconds. And go ahead and document this temperature once it levels out. And you can get the more precise number by going to your serial monitor as well. So I'll go ahead and do that real quick. Yeah, so you can go ahead and record the temperatures that the serial monitor gives out. And I'm going to go back to my serial plotter. Because I want to see what happens when Emma actually removes her finger. So if you go ahead and take your finger off, you're going to see the temperature start to dip. And this can also take a while to balance out. So definitely go ahead and do this a few times, mess around with it, see what trends you guys actually observe. And if you want to document the temperature precisely, again, go to the serial monitor and use that tool. And you can now do some additional tests You can try different heat sources, maybe rub your hands together, make them a bit hotter, see if that makes a difference. And some different heat sources that you can try would be like a lamp, the sun, or even your laptop exhaust fan can work. And then once you've messed around sufficiently with that and seen some interesting trends, you can also try using cold sources. So you can try putting your Lunasat in the refrigerator or freezer. As long as there's no condensation or moisture on it. You can go outside if it's cold. If your hands are kind of cold, you could also use that. You could try a cold pack, and again, just make sure that there's no condensation that could damage the Lunasat. Good job, teams!